told you.
Some morning hip hop, something a little like start a little slower, calm and gentle, not be too abrupt. How do I enliven? This is a macro.
Let's go.
You want to see something cool about Linux? This sound is really crap. So like, if you have a Mac, who has a Mac? Windows computer? Don't be ashamed, it's okay. It's a safe place. So we can actually go over 100%. Computers? More than 100%.
I'll be the baddest. Be the hit the
Anyone here is a breaking 150%, I apologize.
So what you got to say? I hope you're bubbling it, baby. Now bubbling in my way, let it rain. Ain't no sort up in the game. Still want you to stand. Ain't a thing changed. Instead of knocking boots, we be kicking down Gore-Tex. Except it ain't raw sex. Fuck next. Throw your hands in the air. Let me hear you say, oh yeah. Trust you, me, I'll blow up shop. About to blow the roof right off of hip-hop. I rock the party that rocks the body. You rock the party that rocks the body. I rock the party that rocks the body. You rock the party that rocks the body. I rock the party that rocks the body. You rock the party that rocks the body. I rock the party that rocks the body. You rock the party that rocks the body. I'm the MISS, your best from VAA, and I'll be all day.
And after, I have to leave.
Daddy be my pal when I I took your number one spot. I don't skip, then I hop. I'm so hot, so you can't forget me. Not to the yes, y'all. I'ma take a pause, cause I be feeling myself like I was T-Boss. Puff Daddy make a the L-Y-T to the E make them scream. And I'ma show enough be the boss on this team. So all you MCs, how I miss it make you green. I rock the party that rocks the body. You rock the party that rocks the body. I rock the party that rocks the body. You rock the party that rocks the body. I rock the party that rocks the body. You rock the party that rocks the body. I rock the party that rocks the body. You rock the party that rocks the body. Shady.
That's right.
That's me, complicated rap star, me like MC. You see, I'm on to your baby mechanism. How you hit it when you're in it so hot, you keep it sizzling, no ooh, and all of that too. Keep me in the waters of Kalamazoo. Who you come in with? When your posse at? I leave the boys alone. Tell her you won't be bad. I got the cheese, baby. My cheddar's better. I got that milk that I'm a better. Trust you, me, I'll blow up shop. Had a little nick calling the cops. Watch. I rock the party that rocks the body. You rock the party that rocks the body. I rock the party that rocks the body. You rock the party that rocks the body. I rock the party that rocks the body. You rock the party that rocks the body, body, body. I rock the party that rocks the body. You rock the party that rocks the body. I rock the party that rocks the body. You rock the party that rocks the body.
Upside down, you turning me, turning me. Round and round, you turning me, turning me.
I rock the party that rocks the body. You rock the party that rocks the body. I rock the party that rocks the body. You rock the party that rocks the body. I rock the party that rocks the body. You rock the party that rocks the body. I rock the party that rocks the body. You rock the party that rocks the
I just
body.
think it's small, because like, so last year, I did like some big pyrotechnics, completely safe, but big in the legal dev rooms, and the organizer from the United States ran off and was like, you can't do this, they got really angry. So try not to like piss them off too much. If you want to see something more exciting, come to Config Management Camp. Alright, I'm going to just unplug this audio, so hope this doesn't pop. You're going to not get the audio for the talk, because its laptop should go here. Thanks for coming early, everyone. Who's not been to sleep yet? Anyone? Jonathan, you can't sleep. You have sleeping problems. Cool. Is that big enough, or do you want bigger? Bigger? Biggin? Biggin? I'm a professional. I know what I'm doing. All right, so random terminaling. You want to see a quick video from Montreal while we're waiting? It is on. Up. Okay, I'll show you some quick warm-up from Montreal. Hey, David. Morning. Sorry about the VHS quality of this video. This is something that happened in my city. It was a little slippery and people weren't prepared. We're usually pretty good about this. And LibreOffice has some sort of bug which I've been unable to report yet due to laziness. Whoa. And makes it look like a VHS recording. Yeah. It's our city bus. Quickly, come in. Missing the fun of the video. Boom. Don't worry, if you're looking at your laptops, look to the screen. It's going to get more interesting in a second. All you laptop users, come on. So the police are here to save the day. But in Montreal, you don't have to worry, because we actually have excellent CityWorks people who can come to help with the situation. Put down salt. Ensure the safety of all the police cars in Montreal. There we go. His boss is not happy right now. Wait for it. Boom, there we go. Yeah. So, we have to start, right? So, I'm going to start. Hi everyone. I'm going to talk really quickly. If you have questions that you're really stuck, ask me, because I don't want you to be lost. But mostly we'll try and do questions at the end. If the people are watching the stream or recording the stream and mixing the stream, you probably want to see my screen in the mix, not me, because I'll just be flailing my hands and sitting down, but I'm going to show you stuff on the laptop. So let's just talk about what's possible today. I showed you the video. I can give you a little background. So I'm a hacker. I work on config management things. I'm currently employed by this apparel company. Makes all sorts of hats. I write a technical blog called The Technical Blog of James. Who's seen it? Anyone? Just raise your hand. If you haven't seen it, just raise your hand anyway, so I seem really popular. Go on. Excellent. I've actually moved it to my personal domain off of WordPress, so that's a slight change. I'm actually a physiologist by training, so if you want to talk cardiology, I would love to. Just come find me. And really big into DevOps. So I'm just going to give some background. You can't hear this, but it's basically just a video of Beaker screaming because everything is on fire. I did a lot of Puppet stuff for many years, and I had sort of built up designs about things that I wanted differently in Puppet, and did a lot of hacks. They're all on my blog. And I wanted some sort of a new tool. And people are like, don't reinvent the wheel. We have Puppet. We have good tools out there. But I want the nicer wheel, right? Do you want the nice wheel? If not, you got the ugly wheel. Ugly wheel? Nice wheel? You guys are still sleeping. Who's really shy? Just raise your hand so I know where you are. Thank you. Excellent. Good. So I basically came to the question, is there an existing tool out there which is good enough for what I wanted to build? We'll talk about that later. Is there? So this is the gentleman who I bring to all my talks to answer this question. This is the Nope guy. Dear goodness, I hope your water person arrives. All right, so this is really what I came to the conclusion. So long story short, I've sat down and started working on a project. It's been, I think, just about 2 years since I first sort of started talking about it publicly. And we have a logo and a project, and if you promise to use a sticker on your laptop, come up quickly at the end and I'll give you one. So there's two main parts of the tool. There's the engine and the language. We've given lots of talks about the engine. And the engine has three main points. I'm just going to show you about them quickly. It runs in parallel. So who's not familiar with config management? Just let me know. Don't be shy. Everyone sort of assuming some base knowledge? Or too shy to tell me? Which is okay. Long story short, so the graph of resources that we apply, we actually can run that in parallel. We are event-driven, and we work as a distributed system. So I'm going to go through these three things. So here's just a graph of resources that you might find in a traditional tool like Puppet. where you have all the blue boxes here represent the different resources that you might want to run. So a file that should have a certain contents, a service that should be running, and a package that's installed, and so on. And the black arrows represent the dependencies between those resources. So do this and then that, and so on. And do this and then those two, and so on. And what most tools do is they do this thing called a topological sort. And that's this red arrow. So they just they find one safe path through the thing so that they can actually do everything with respecting the conflicts, or the dependencies. But in Mgmt, we actually run everything in parallel. So everything on the left, the same time as everything on the right. And once 1A is finished, we can run 2A and 2B in parallel, and so on. Does that make sense? I have a demo of this, but I'm going to show you more exciting demos instead. Is that a deal? If you want to see this in action, we'll show you. So the second is, I said we're event-driven. So let's just actually show you a demo of this. So I have a little hello Belgium example. So on the left here, I'm going to run Mgmt. It's this little engine with some code. The code I'll even just show you. Hello Belgium. Can you see that? It's big enough. It's just a simple file resource. It looks kind of like Puppet a little bit, where it says, here's the file path and the contents. And let's run that here on the left. And on the right, you can actually see that this file gets created, and it has the contents we expect. So nothing particularly special. But here's the cool thing. If I remove the file, you can see it comes right back. So I can remove the file, and it comes right back. So the whole thing is actually in real time, keeping the state of the machine. And it works so quickly, you can even remove the file and, and cat the file. And even as fast as I run this, the Mgmt engine will always wake up and fix the state. Just come in. Hurry up. Come on. And the thing is, it actually works quite quickly. So even if you run something like the watch command, just to run this command over and over again, you'll see that the Mgmt engine is actually waking up and spinning constantly, and it's always keeping the correct state, or basically almost instantly. Any questions about that? Yes? So the way all of the different resources work is each different resource has a way to detect when events happen. And they typically ask the kernel or some other mechanism to wake them up to do that thing, and then it goes back to sleep. So most of the time, Mgmt will be just sleeping and waiting for file resources it's on iNotify. And when it wakes up, it checks the state because it said something might have changed, and then goes back to sleep. And we do this for services with systemd and all sorts of other different things. So I'm going to show you a little bit more if you're interested. Want to see some more demos? Yes? Okay, good. So just before I show you another demo, so I think this is what config management should have been. Some people call what I'm doing choreography because we're doing sort of fancy automation stuff, but I think this is another technology as well in addition to config management. Anyone have an idea what I'm getting at? Don't be shy. You are quiet. It's early, I know. So I think this is also a bit of monitoring. So if you think about how when you set up something in production, you set up all your config management to set up all your services, but you can't put it in production because you got to have everything monitored so you know if something goes wrong. So in that situation, we actually have some of that built in basically per resource, so you don't have to do that extra work. Anyways, let's do a little bit harder stuff. So here's a simple topology. What's this kind of topology called? Client server. Jonathan, you know this. Jonathan sends patches to our project, so he knows this. What's the problem with this topology? Anyone? Call it out. Don't be shy. What? I heard it a little bit, but you're quiet. So it's a single point of failure. What's another problem with this topology? Traffic jam? Yeah, so there could be a performance problem. So if you have many, many clients all connecting to the server. It's still a very well-known topology. This is something called a central orchestrator. So you have one thing that goes off and connects to a whole bunch of machines. So what are the problems with this topology? Same sort of thing, right? It still can be a single point of failure and still can be a performance bottleneck. So this is just a fully interconnected network of hosts. In this particular topology, there's a problem, which is if you have a very large number of these, you just would have too many connections, so that doesn't work. So at Mgmt, what we actually do is everyone comes together in a cluster, and some small initial set become primary machines and form this interconnected cluster. And on top of that, they run etcd, which is a distributed key value store that's built into Mgmt. And the cool thing about that is there's not a connection count problem, and everyone else that's not part of the select few in the center can just connect to any one of those, and they can all exchange information that way. So we have this free sort of temporary database if we need it. And if one of these dies, that's okay. One of these can take over. And since we have all this available, we can actually do some cool things and exchange data. So let's show a demo of this. Exchange. So I'm going to show you, I'm going to boot up one machine at a time, and they're automatically just going to cluster together, and they're going to put some data into this cluster. And we're going to show you that on, oops. I'm going to run the first one over here, and it's going to actually just remove some files. So we're going to watch just so you can see what's happening. There we go. So what I'm doing is each machine, it's going to show you the code that's actually running. This is the code. And what I'm doing is they're just taking a random value and putting it into this database and sucking every random value down. And I'll show you that a little bit more in detail. So the first machine says, oh, I'm the only one, I'm hostname 1, and here's the random string that I put into this database. If we were to start up a second one, just get number 2, and very quickly they'll cluster together. Oh, that is the wrong function, sorry. So if you see the second machine now has H2, and you can see everyone has sort of passed data back to each other in this way. So if you think about this, like imagine you had a whole bunch of people or they came into a conference room, everyone said, hi, my name is hostname 2, here's a random string, and you would learn everyone else's secret value. So you can kind of exchange and do a service discovery that way. Similarly, if you have like a load balancer, you might have all these load balancers. This load balancer is waiting for a whole bunch of web servers. And as the web servers come online, they say, here's my IP address. And then the load balancer would add that to their load balance set and sort of do this dynamically on the fly. So you can see you have 2 there. Should we start a third one? Sure? All right, so we start a third one. Just have some. There we go. So if we run a third one, you'll see very quickly there's a third one that instantly wakes up in real time, right? So you don't have to wait over and over again for Puppet to run for this to happen. It all just happens in a few seconds or under a second. Anyone completely lost about this demo? I know it's a little bit abstract. I'm trying to make these things more concrete, but it's still early, so yeah. Yeah, so the question is like, is this broadcasting? It's actually, so we never actually orchestrate. So what we're actually really doing is each machine independently has some algorithm that they know to follow. And they know that when they start up, they should look for values in a certain key space because they're going to be expecting something there. And then the other machines put values there, and then they say, oh, the watch returned, I'm going to do something with that value. So it's kind of like a publish and subscribe model for that sort of thing. So I'm going to show you some more demos if you want. Should we continue? Yes? Okay. So I showed you this sort of stuff. This is all stuff that the engine does, and the thing is we want to be able to program this engine to do all sorts of fancy stuff, particularly in a distributed system. So this is sort of the design goal of the language. You can read this if you like. The language has some properties that we wanted to achieve. One, to be very safe. One, to be very powerful. So if it restricts you, the way some people were upset with Puppet restricting you, that wouldn't be helpful. We also want things to be very easy to reason about. So testing and safe languages are great, but if you cannot read your code and really understand what it's doing in complex systems, it's very difficult to get work done. And here are some of the properties about the language. But I'm going to actually just show you the language. So I'm going to show you this demo right here. This is the code. We don't have syntax highlighting yet, so I kind of did this manually. So you have here, we have this year constant, which seems to be you multiply all of these values together. And we add that kind of in the weird order to this date time function, and then put that into a struct, and we have this load function, which is also a variable in that struct, and then we print out that struct to this file. So what's going on? Let's run this and see what happens. Oops. So I'm going to run this on the left. Just going to delete all this stuff. So I'm running a watch here on the right. Oh, come on. All the people are waking up early. So what's actually happening is every second, it turns out that this code is actually running. It's actually running as a stream, so it's a reactive programming language. But it turns out that it decides that the output changes every second or as often as it wants. And it's pushing those values, that graph of resources, into the engine every second or as often as it needs. And in this case, it's just changing the file contents over and over again. So you actually see, just by running this watch here, I'm just looking at the contents of the file really, really quickly, this is what's actually happening in real time. So you can see the number of seconds in a year from now is going up every second. If you look at this value here, this is the load average. So the kernel actually produces a load average in top, and every 5 seconds it sends a new value. We notice that it sends us a new value, and then we just, in this case, display that value. And just to show you how these things, these variables can be reactive and interesting, I have actually even this VU example. So what's actually happening is I have a function in the language which is actually reading my microphone from my laptop right now, and it's spitting out the volume from 0 to 1 as 100% sort of maximum, and just displaying that as a VU meter. So if I were to make some noise, you can see it goes up really loudly. So we can actually now model these reactive variables in our language and do clever things. So if, for example, the volume was really loud in your office, maybe people are screaming and fighting, and so you should have your tool automatically set the production server to read only or something. Right? I mean, that's kind of a silly example, but anything that you want to imagine and build, it's really up to you. And just to prove to you that this is fake, come in if you want. Okay. Yeah, everything's good. Yep. Just to prove to you that this actually is working correctly, I'm going to be very quiet, and when I point to you, try and make a lot of noise, and we'll see if it actually goes up. Are you ready? So the applause meter here was not very good. So you guys are a quiet audience, but you get the idea, right? And this is just one reactive variable that exists in the language. You can build your own. They could be just the time of date. So when you get to Friday, you automatically turn off certain services. Sorry, we're closed for the weekend or something like that. I mean, do these things, model them, because we made this assumption with Puppet and other tools that the things are static. That our infrastructure, we build our infrastructure, it stays basically the same, Puppet has converged, everything is happy, until we push a new bunch of code. But in fact, we'd like to model these things. So as error scenarios change, as failures happen, as different constants, or different variables in the world change, let's actually model these things and build different stuff.
But again, it brings things to troubleshoot if something go wrong, right?
So the question is about troubleshooting?
Yeah. You mentioned if your configuration is static.
Yep.
Just you said it once and it remains the same, but in that case, you might have a weird situation which you need to pinpoint next time.
Yeah, so the gentleman is saying, well, if this changes all the time, it might be more difficult to debug. It's a yes and no. The fact that you are pushing something every time you want to make a change can actually be harder. Then you've got one code base and the next code base and the next code base. So that's really difficult to reason about. In particular, because when you want to do dynamic things, you typically have to glue more than one tool together with shell scripts and so on. And then you can't actually type check usually between the boundaries of tools and so on. So that's even more difficult. And in particular, the fact that we have this FRP language makes it very, very safe to find these bugs for you. So yeah, certainly there's some different problems, but overall I think we're going to be better off. That's just my opinion. So let me show you some more demos and try and convince you more of that. Walter, do you think you could find me a bottle of water, please?
Yeah, that's one way.
Okay, cool.
So, can I ask one question?
Yeah, quickly.
Just curious, do you have a detection of cycle dependencies? I mentioned one script.
Wait. I'm showing stuff. So just please wait. All right. So if you're really stuck and you're lost, ask a question. Otherwise, I'm going to show lots of stuff and should answer most of your questions. So just to show you, so I told you now that we have these variables that are changing over time. So what we can actually do is we can actually look back historically at old values, right? Because since they already exist, so here's an example with date time equals this variable. And then over here, we can actually take this datetime variable, put these curly brackets and index around it, and get the previous value or the previous value before that, and so on. See what I'm doing there? And if we run this, So if I run this example here, we're just putting them out into a file. Oh, awesome. Thank you, sir. If we just run this here, you can actually see that we are just actually showing the current date and time and the previous date and time and so on. And we can actually use this to do some interesting things. So if we have that property, we can build on that. So what is this a picture of, anyone? Yeah, it's a thermostat. You can see it's in the correct Canadian world units of Celsius. Unfortunately, this is a photo that my parents took, which was on a BlackBerry phone and not very good quality. So I found the only one on the internet that looks similar. Unfortunately in the wrong units, but just so you can get a clearer picture. And these things have an interesting property, besides setting the temperature in your house. What is the property? What? Hysteresis, that's very good. Did you see my talk before, or you know what this is? Good, excellent. So they do have this property called hysteresis. Grab a seat. If you don't have a seat, right over on this side. We didn't implement the FOSDEM compression algorithm this morning, so hurry up, you're late. You're late, you're late. So they have this property called hysteresis. And what that means is, suppose you have a thermostat, it gets to 20 Celsius and it turns off. And it's really cold outside, so the room gets colder. But it drops just below 20 Celsius, so the temperature clicks back on, and then it clicks back off, and it will sort of cycle back and forth in an oscillation as you were actually talking about. This would be a problem for the thermostat. So, in fact, hysteresis lets it so that you can actually have a delay or some sort of threshold built into the system. So when you get to 20 Celsius, the heat's going up from 18, 19, 20. When you get to 20, you click off, and then you wait till it drops down below 18, and only when you drop down below 18, and then you click back on, and it will heat up. So it actually lets you have a delay and a threshold in this process to prevent these rapid oscillations. So let me show you an example of that. I can actually just show you an example. I'm going to run this here. And this example, I'll even show you the code. This is a dev example, so let's hope this doesn't crash, but I think it should be okay. This is just a short hysteresis implementation. And what we're doing is we have a virtual machine resource. So we can actually declare the state of a VM or two VMs and so on. And we just say, here's a VM. It has one CPU, it has some memory, and here's the state, shut off or running. So basically to power it off or run the shutdown command on it. And this little variable, this Boolean, is the output of our hysteresis function. And it says, if the load on the system is really high, then shut down the machine. Otherwise, turn it back on. And that hysteresis function will actually make sure that it does that threshold that I was discussing. So for example, if the load gets really high, it'll shut down a machine, which maybe that means you want to reschedule your VM on another host because there's too many users, too many VMs, and you're overcommitted. So you might want to move that across. So I'm going to run that here. So what I'm going to run just in a loop so you can see what's happening, I'm running this watch command that's going to print the output of some file that I'm creating just to show you what's happening on system. And then I'm running verse list. And you can see that Mgmt is running, and it created these two VMs. And if we actually now cause the load to go up, let's see what happens. We're just going to run some fake commands. So normally this would be the VMs that are running, Bitcoin mining or whatever it is people do with VMs these days. And watch what happens. Here's the load, the current load right here. And here's the threshold of 1.5. And watch what happens when we hit 1.5. Just make this go a little bit faster. You should see one of the VMs shut down. Okay? All right, getting a little warmer. Laptop is heating up. 0.9. Are you excited? All right, good. All right, so what's going on? So it hit 1.5, and you see it shut down one of the VMs. So actually, I'm going to just kill this stuff right now, and we're going to let the load drop below the threshold. And when it goes below 1.5, remember, I had this hysteresis, so it's not going to turn on the VM until it's below for about 10 seconds, and then, assuming it doesn't crash, it's going to turn the VM back on. So we're at 1.53, we're almost there. 1.49, so nothing's happened. 5 seconds going by. 5 more seconds, and it should actually turn itself back on. 3, 2, 1, boom, and there it is, back on. Cool? You like that? I saw a few people nodding. Oh, thank you. Okay. So what have we actually built in a few lines of code? Auto-scaling, yeah. Like, totally. Who has built auto-scaling in their infrastructure? Right? Very few people. Maybe the rest of you are shy. But the thing is, it's a pain to build auto-scaling. You have to glue different tools together, and it's so hard, and reasoning about it, and so on. So if we can actually model this in the language, you can actually just have cheap auto-scaling of all sorts of different things, of VMs, of all sorts of resources, anything that's in Mgmt, any resource, package file service, VM, EC2 instance, and so on, and way more. So that's sort of what's possible. Any questions about this before I kill it? Don't be shy. No? Okay, we're good for time, so I'm going to show you some more demos. Unless you're fed up. Do you want to see more demos? If I don't have an enthusiastic yes, you're getting no more demos. Do you want to see more? Do you want to see more demos? All right, thank you. Slightly better. Versh. Walter wanted me to wake up the room. He gave me 20 euros to do so, so here I am. So just briefly before I show you some more demos, I'm going to tell you a few interesting properties of the language, and this gentleman I think should be happy. So the language itself is this functional reactive programming language. It's a very safe language, but as I said, the reactive nature makes it very powerful and lets you model these complex things, and I'm going to show you some more things later. But we don't want crashes in our system, right? That would be bad. We don't want errors. But if we can eliminate all of those errors with the FRP, that's probably going to be the case for almost all scenarios. But even if for some scenario we found a way to crash the engine, crash the language, what's actually happening is the language is running and it's outputting a stream of graphs. So graphs are those circle and arrow things that run on the engine. So it's saying, here's a graph, run this graph over and over again, and the engine is very efficient at taking a graph and switching to the next graph and switching to the next graph. That's like a puppet run, another puppet run, and so on. And we're very efficient at doing that, and that stream comes right through and gets run basically in real time. The catch is the cool thing is if the language crashes, it just won't spit out a new graph, and nothing bad will happen to your system. It just won't make any changes for that time until you fix things. So that's kind of a cool property. Hopefully it should help you not destroy a data center because something went wrong. The code itself in the language, remember I had that first example which is kind of out of order? You probably shouldn't write code in an out-of-order way, but it turns out that the code actually is a graph, another graph itself, because it's actually just modeling the flow of data, kind of like an Excel spreadsheet where it just knows what to update in what order. So you should write code in order. We might enforce that as a compile time requirement, but for now at least, you could write code this way. Variables are actually mutable. So if you did something like x equals 4 and then x equals 5, this would be a compile time error. The compiler will stop you. And this actually prevents a whole class of bugs. I won't talk about that in detail, but if you're into like programming language design and so on, there's all sorts of bugs you can make that destroy data centers if you allow this. And we don't allow this. So hopefully your bosses and your data centers will thank me. Is that cool? Yes? I want to make it safer, right? I mean, the whole idea is to not just let you write code that will type error randomly partway through. I talked about hysteresis and showed you an example. So hysteresis turns out just to be a real property that humans sort of intrinsically know about, and lets you say, okay, I want to do this thing, but slow it down. Maybe it prevents an oscillation, as the gentleman was asking about, and so on. And we can actually have different kinds of hysteresis. So with a threshold, with a time threshold in there that we wait some number of seconds before we get back in. Alternatively, we can actually have sequence-based hysteresis, where we look at some past number of values, whether they be 5 minutes ago or so on, and model all sorts of real scenarios. And in particular, all the variables and functions in the language are reactive. So date, time, load, and so on. Even error scenarios. The error part actually isn't implemented, but in the future I think we'll probably see error streams. So you'll actually get a stream of hopefully normally no error, but when suddenly you start receiving error scenarios, maybe it's hard drives failing or whatever it might be, you can actually use those values to model your response. So if you just had one small error coming in, one small error, it's just maybe some small isolated thing. But if you suddenly see a high rate of errors, maybe something really bad is going on. So a data center went offline in another system. So modeling these things in a safe way is what's going to be very simple to do in the language. And really, it's going to be up to you to sort of imagine those scenarios. I have more demos, but I'm just going to sort of go through, just close out the slides a little bit further. How can you help? Like, this is about you. This is a free software project. How can you help? You can use this, test it, patch it, share it with your friends, document it, start it on GitHub if you think it's cool. You can write a blog post about it. Walter's writing a blog post about it. Tweet it, discuss it, and just hack on it. Hack on it with your friends. Actually, this is a screenshot I took a week ago. We're doing pretty well. I think we just crossed like 1,100 stars or something, so there seems to be a lot of interest. And just now, I think in the last week or two, we're actually making it really usable for production. Previously, like a week ago, there wasn't really this language. It wasn't available in Git, but it exists in a feature branch, so feat/lang, so you can play with this. And in the coming weeks, I'm going to probably have this in Git master and a proper release. Oh, good morning. The Godfather himself. Mgmt itself, unfortunately, does not have a home right now. I was working on this a little bit before I joined Red Hat. Red Hat funded my work. They're a Linux company for about a year or two, but because of politics and Ansible, they've defunded my project. So I'm completely homeless in terms of funding and just working this on my spare time, buying expensive stickers for you folks. So if you'd like to help this project or you know where we can find a home for it, please let me know, and so on. We're going to recap. Do you want to see a few more demos first? Because we have some time. Yes. All right. So what demo should I show you? Let's see what we have in the example folder. All this is in Git, so you can actually do all these examples yourself. So what I'm going to show you, an oscillator demo. So just because someone asked about it. So I'm actually going to just make this, let's do this way. Oops. So let's say you want to really build some fancy, complex machines. I mean, these are living, breathing things. So this is a new demo that I built. I'm going to do this just as a single machine right now, but you can expand on this to do it with a cluster of machines. Come grab a seat, if you can. What we're actually going to do here is we just have some namespace, call it whatever. And over here we have this key value resource, which is going to take a value and put it into this database, whatever it is. Is this distributed database? Good morning. You're late. It's going to put it into this distributed database. And over here at the top, we have this reactive function, same as before, that can actually look up those values. So look up everyone else's values and our own. And we're looking up that value, and if that value is state equals 1, we're going to do this stuff. If that value is state equals 1, then we're going to actually write to this state file to say state equals 1. And then we're going to write the key to be state equals 2. And then remember, this is reactive. So boom, it's going to say, oh, now we're in state equals 2. So then it's going to notice that this function is going to change. So then we're going to be in state equals 2, which is going to print out into the file state equals 2. And then run this key value thing, which is set us to state equals 3. Same sort of thing is going to happen again. If we're in state equals 3, it's going to print that out in the file and take us to state equals 1. And then that's going to start at the beginning. So yes, we've actually built an oscillator. Okay? Now, let's run this just so you can see what happens. We could actually run an exec sleep in each block so that it would slow it down. We're actually just going to run this in real time for now. Oops. There we go. So I'm going to run this there. All right. You can see that on the left, stuff is going on. And if I actually just show you, it's just going 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay? Kind of crazy. I'm going to kill it because I don't want to turn my computer into fire. So obviously, this is kind of an unhelpful oscillator. And in the language in the future, I think we'll be able actually to do some formal analysis and detect these sort of things. But the truth is, we might actually want some sort of oscillators. Maybe some slower oscillators. So it is turning into, 10 o'clock. People are waking up. So it auto-scales some machines to higher capacity because web traffic is going up. At the end of the day, slow them down. When it's the weekend, it's really low. And model all these reactive changes in your infrastructure. So it's really going to be the autonomous sysadmin that's part of your cluster. There's actually a project, since we're just talking about it, by CoreOS, which Red Hat recently bought. They have this operator pattern. Has anyone heard about this? No? Yes, some people. If you look at it, there's this operator pattern for sort of doing similar sort of things where you have a sort of sysadmin autonomously making decisions in your cluster. The problem with the operator pattern is the operator pattern assumes that there's one single point in your cluster which decides what to do and basically orchestrates decisions. And in particular, this is quite different from that. What we're actually doing is we write this code, which is effectively your algorithm, and we push that to every machine in the cluster. And then those individual working units, not a central thing, those individual working units know what their algorithm is, and if they're well behaved, they all follow that algorithm and hopefully organize, self-organize, and do something in the distributed system that is our cluster. Does that make sense? Now, you might think this is a little hard to do. Like, how do we organize all these distributed system things? So the good news is we do the hard stuff for you. Because of having the RAF protocol built into Mgmt, you don't have to worry about those things. You just have to use those functions that we provide you that are reactive. So exchange, which passes values back and forth, and so on, and other sort of values as well. Does that make sense? Yes. Yeah? I have up to 2 more demos I can show you, but I just want to take a quick break if anyone has any really, really important questions they want to ask. They're really confused or lost about.
Maybe not important.
Yeah, sorry, important is the wrong word, but if you really have a question that you really want to get out, I can, happy to take 1 or 2 just in the interim.
Yeah, let's say you deployed a
You?
script.
You have to raise your hand,
Yeah.
and you have to ask the password. Just kidding. Go ahead.
Yeah.
Thank you.
You're welcome. So let's say you deployed the one version of your configuration.
Yes.
And then you deployed somewhere else, deployed another one. Wouldn't they run in parallel?
Great question. So the gentleman in the front is asking, what if you deploy one version of your configuration and then another and so on? So I'm actually giving a talk at Config Management Camp in Ghent, and I'm giving basically this talk again, but then there's a second talk that I'm giving which is going to talk about all sorts of kind of advanced topics that I haven't really presented elsewhere, and one of them will be deploys. But basically the way it works is obviously you have one bolus of code that you're running in your cluster, but you might eventually want to change your mind and write some new code and push that out. So what actually happens is you actually use the MGM tool to bundle all of the code in a little sort of, think of it kind of like a tarball, and actually push it to any single machine in the cluster. The cluster will replicate it around so that everyone has the instructions, the algorithm, and then based on either a rollout mechanism or immediately, it will then switch over and run that new version of the code. And there's different ways we can do this. I don't really want to get into it today, but if you want to hear more, come see my talk at Ghent. Great question. Any other quick questions? If not, I can show you another demo. Questions? Anyone? No? More demos?
Yes.
What?
Question.
Wait.
You promised to show the demo which will explain cyclic dependency detection.
I did.
Whatever.
I did. I showed the oscillator.
Yes, later.
You were sleeping.
No, it's
I saw it. There's drool. I can see the drool. So let me show another demo, and then ask me again at the end. So this is running just on a. This is running on a remote machine. So please turn off your torrents for just a moment. So what I've done on this remote machine is I've started up Mgmt, and that's running. And I'm just going to hide this in a different screen. And so I've started up Mgmt. Excuse me. And what I've done is I've logged. Mgmt has actually started up a VM on that machine. So remember before I had the different VMs running? Here I'm actually logging into one. And right here, oops. So this is the host. You can see that there's the Mgmt, the VM that Mgmt started up. And if we log into the machine, it's over here. And if we run like lscpu, you can see it's a VM. It has one virtual CPU and so on. And what I'm going to do is I'm actually going to run a grep command that's just going to run lscpu in a list. So we can actually see the number of CPUs in that VM that Mgmt has started up. With me so far? Now, remember how variables can be reactive in Mgmt? So just to demonstrate that, just to make it a little bit more fun, I made this crappy little bash script, which I'm going to run on the Mgmt machine. And when I push the plus or minus key, it's actually just going to push a new variable into Mgmt, and that variable is the CPU count. Right? So I declare the VM name, vCPU number, but that's an integer which is coming from this little script. And watch what happens when I press plus. You see what's happening to that value right there, going up and down? So what's actually happening? The resources themselves are quite powerful. So as we change the number, could be the date and time minus some value or anything. It actually is pushing that value to MGMT. MGMT reacts in under a second. It says, oh, the CPU count in my VM is different from what actually was requested, and then it actually runs the libvirt CPU hot plug or hot unplug commands to change that count in the VM. And then in the VM, you can actually see that happen because we're running LSCPU, which just tells us. Is that cool? Let's do it again. I like doing this. You can just go up and down. It doesn't seem to crash. And this is stuff that was built because expensive or rich customers of big mainframes or whatever it is a long time ago were like, I have 4 physical CPUs on this server. I would like to take one out and put a new one in. Or buy a machine with only 2 and then order some more and just plug them in because they did not want to turn off their databases. Just completely absurd. But now we can actually do this in real time in VMs. I think that's how it started, but don't quote me on it. So imagine you're running your cluster of stuff and maybe all of your customers are not using much CPU. So you take away some of the vCPUs from them, but suddenly a lot of load comes in, so you add those CPUs in real time to those VMs. So you can actually give your customers more capacity basically for free by modeling the load and all this sort of stuff. So use your imagination. My goal is not to say your cluster must be built this particular way. My goal is really to give you a tool that lets you model what you want to build for your infrastructure. Do something sane, please. And yeah, make sense? Any other quick questions? I have one more demo that I can do, which I was going to only do at Config Management Camp, but if you promise to give me lots of applause at the end, I'll show it to you early. Is that a good deal? Yeah. All right. Let me just take away some of these CPUs. So, this is a brand new demo. We got 15 minutes, so I'm going to kill this. So I've never actually given this demo before, so you might... Is it okay, Walter? Hi. Okay. All right, cool. Why? I like to see the best stuff for Config Management Camp, but anyways. So, let's show you an example. So, who's done some Puppet? Raise your hands. Oh, okay. So this should be easy. So, in Puppet, you have code that sort of looks like this. Node, I don't know, database, blah, right? Do stuff? Is that right? Ish? I haven't done Puppet in a while, so, package, whatever. I think I need another one over here. Sure. Installed. Great. Does that make sense? So Puppet, what? That's right. That's right. Yeah, there we go. Yeah, it's been a while. So I moved the syntax. It's sort of different in MGMT, so you can see my bias. So you have this sort of thing. So Puppet has this node expression, which is like a specific thing for Puppet. Anyways, so this is crazy. Especially because, then you can do things like node, like database star, to have any of the database prefix machines and so on. What if you just want this to be dynamic? Yes? So let me show you what I mean. All right. All right. So I have this example here. I think it's this one. So you'll have to use your imagination because it's a bit abstract. So here's what I'm doing. So this is just some examples. I have this options struct, which just has a few fields in it. So strategy equals RR, max equals 2, TTL equals 10. And I have this function which is built into MGMT. There's a function API, so you can build these yourself. But here's one that comes with MGMT. And it takes a namespace and those options, and it returns this variable set. And just to keep it simple, I'm just going to print out a file which has the host name that this machine is, and just prints out the whole set. So I'm going to run everything on my same machine, but you're going to see the perspective of each host. So if I just run h1, sorry. So, basically I'm running the code, and I can just say, pretend that you're hostname h1. So I'm going to run that over here, and you can see for machine h1, you create this file scheduled h1. And just so you can see all the files that get created, one for each machine, we're going to just run this tail. So I ran one machine, and it just said, okay, the scheduling result is h1. I'll get to what that means in a second. Let's start up a second one. and start up a second one. And just in case you want to actually see what I'm doing here, well, all I'm actually doing when I run MGMT to cluster them is I'm timing it for no particular reason. I'm running it, I'm pointing it to the language code that I want to run. I'm overriding the host name, so I'm just saying pretend your host name H2 because I'm running on the same machine. And then the seeds variable points the new machine at any of the existing machines in the cluster so that the clustering can automatically happen. And then these last two options here are just different ports because I'm running on the same machine. And then there's some debug options. So I'm going to run this. Watch. So you can see now on hostname H1, it's scheduled H1 and H2. And if I run a third one, okay, if I run a third one, you'll see H1, H2. So what have I built? I've actually built into the MGMT DSL a function which is a reactive scheduler. So now you just literally have some code. If code is on the first scheduling set, do some stuff. Right? So if you're used to building a scheduler, suppose you wanted to have some number of web servers, between 0 to 10 of them, on whichever of your machines that fit a certain pattern. This can actually happen in real time. And if you look, so they've all just, the scheduler has picked up to 2. Remember I had max equals 2 at the start? So I said pick up to 2 hosts, please. And it's picked H1 and H2 for every perspective. But if I kill the second machine, watch what's going to happen. So this machine's going to die, so I'm just going to kill it. So this file is going to stay. But watch what happens to 3 and 1. So the host number 2 died, and number 1 and number 3 said, oh, host 2 doesn't exist anymore. We said we should schedule at least 2, so we're picking 1 and 3. See that? If I bring host 2 back up, so remember this one's dead, so the file just is stuck on my file system, but normally this machine would be offline. Watch what happens when I bring it back up. You can see now it picked, in this case, and moved them back to H2. And you can actually specify different scheduling algorithms and so on so that some number of machines are picked automatically, reactively, in a distributed way in your cluster. So what could you do with this? Suppose you wanted a container scheduler. You could have, if in set, have container resource, and we have an nspawn resource. So I might show that demo at config management camp, hint, and so on. So different sort of things like that. And build these things and just use your imagination. Scheduling is one example. There's others that you might want to think about, and so on. You like that? Yeah? I know it's a lot, but I figure you guys are a smart audience, so I'm going to show you. So let's just recap. You can't hear the audio, but this is just Arthur Benjamin saying he's going to put the cap back on his pen. It's a recapping joke. It's not very funny. So there's a few places you should know about. We have an IRC channel. I'm sorry there's no Slack or whatever the other cool things that people are using. I'm not very cool. It's MGMT config on Freenode, so please hang out with us. We're 50 or 60 some odd hackers in there. We have a Twitter account, which is normally a bot that you can just tweet stuff out on our behalf, and some sort of hashtag. I'm not sure how Twitter works, but you can find out. We have a mailing list, super low volume. I announce new releases and sort of new stuff that's coming. So if you want to join or if you have questions, you can subscribe. There's a few links for you to know about. There's a technical blog of James, which you all know about, right? Yes? You're going to check it out. purpleidea.com/blog. Super, super cool. Totally not biased. I'm going to be releasing a blog post about the language with more details very, very soon. There's the GitHub page, so purpleidea/mgmt. If you want to see a whole bunch more demos of things that the engine itself can do, there's a recording of that. There's a few others listed. There's another demo of the language which doesn't show as much stuff, but does exist as a recording. There's this one and I think one from LCA that's also there. If you look on my blog, I have about 5 or 6 other articles about the engine, and you can read those to learn all sorts of other cool things we can do. And you can find me. I'm Purple Idea on Twitter and IRC and all of these cool things at Gmail if you want to send me like high fives or something. Tomorrow, cheap plug, tomorrow in Ghent, which is a 30-minute train ride from here, there's config management camp. Do we have space available still? Yeah, so you can come. It's free. You have to sign up, but it's free to come. It's a 2-day thing, so the first day I'm going to give this talk on the 5th. On the second day, I'm giving the super hard talk with information about deploys, oscillations and scheduling and stuff like that. And on the last day, on the 7th, we're going to have a little room. We're going to be hacking. That'll help you learn how to build stuff and sit and do Mgmt and write code and write patches and get involved. So come check it out. I will be there giving a talk. We have Jonathan Gold here in the audience. He's done some excellent work for the project. He will be there also giving a talk. And Felix, who is probably not here, will also be giving a talk about how you can take existing Puppet code and have it run on our engine really, really fast. So we can actually compile it to work that way. Jonathan Gold, you should know. What? You like that? They're excited about that. Yeah. Jonathan Gold is unemployed. He has been getting into DevOps. So if you want to hire a Golang hacker, potentially even one that can build some Mgmt stuff for you, he's the guy to talk to. Stand up so everyone can see your beautiful face. He was supposed to send me a slide so we could actually put a slide in my talk. But there you go. Very unemployed. You could hire him. He's going to be very poor very soon, and I'm going to be very poor next. So if you are looking to hire people, great chap. He's been writing patches, so I got to plug him. Sorry, people. There's no like corporate overlording here. This is just some nonsense. You might like this, Jonathan. Yeah. Jonathan's an accomplished magician, so he could probably give better talks than me too. If you like this feedback, please help me DDoS the conference organizers. Go bother Walter. Find Alistair if you know Alistair. Go up to the info desk. Say, like, can you help me find Alistair? I have something important. I need to talk to a FOSDEM organizer. Tell them you like my talk, because they keep rejecting my main track. So, oh well. Thank you very much. So I think I have 5 minutes for questions.
Yeah.
I have 5 or so minutes for questions. Any questions? And I have a talk right after this. So right after questions, I'm going to run out of the room to the legal room. But I will be around to give you stickers really quickly if there are no questions, or you can find me in 30 minutes at the legal room and get more stickers. So question. If you're going to leave, please do so quietly for the people that want to ask a question. Yes, question. Oh, yes. Hey, Alessandro.
Maybe you already put that. Some of the available resources now.
The what?
The resources you are managing now, the kind of things you can manage now, and what you plan to manage in the next.
Yeah. So, I guess it's hard to hear the questions, but question. Come get a sticker. We'll do questions on IRC. Thank you.
No, wait, hang on. Hey, wait. I hand it to you. There you go. I like to give it. There you go.
Yep. Using it 10 times. How can we help you get involved? If you're a pro Golang coder, we'll have issues for you to tackle. If you're a new Golang coder or non-experienced, we will mentor new users. Jonathan has been mentored. He's still alive in here, so probably safe.